All right, so problem 17, we implemented this exercise program, and then we're checking job satisfaction. So we're doing a before and after for each worker, so we're going to do a match paired t-test here. Okay? So we're just going to take this right through. The parameter here, mu of d is the mean difference in job satisfaction for each worker who participated in the program. In the exercise program. Okay, the null hypothesis, mu sub d, null hypothesis, mu sub d equals 0. And the alternative hypothesis is we expect their job satisfaction to increase. Okay. The assumptions and conditions, okay? The workers were randomly selected. Okay, 10 workers is less than 10% of all workers. This is paired data. Okay, and then we got to check the nearly normal. So what I did is I put in the before in L1 and the after in L2. So in L3 I'm going to do L2 minus L1, and that's what my L3 list is going to be. And then I'm going to go to plot, and I'm going to do histogram for my list 3. Okay, and okay, so that's what my data looks like. So my window goes from -4 to like 27.25. So I would copy that down, and I would say that the histogram of the differences is roughly unimodal and symmetric. And again, you would copy down that histogram. I just don't have time to do it now. Name the test. This is a match pair t-test. To test parameters and statistics, I'm going to go into my calculator and I'm going to say, okay, I need 1 bar stats for list 3, and my mean difference is 8.5, and the standard deviation of my differences is about 7.5. Okay, so X bar for the differences is about 8.5. The standard deviation of the differences is about 7.5. N is 10. Degrees of freedom is 9. Obtain P, I'm going to do X bar minus 0 over S divided by the square root of N, and that's going to be my T value. And at that point I'm going to go to stat test, t-test. I'm going to take the data. My null is that the difference is 0. I'm going to pull from list 3. I expect it to be greater than, I expected job satisfaction to increase, and then I'm going to draw that up. And that's why you don't leave your stat plot on, because that's what it just did. It just drew that in there. So as you can see, my p-value is 0.0029, and my t-value is about 3.6. Okay, should shut your stat plot off. I didn't, but okay. Okay, so this is T equals 3.6 and P equals 0.0029. So we're going to reject at the 0.05 level. So there is strong evidence that average job satisfaction increased after the implementation of the exercise program. Okay, and then when I reject a null, I like to do a little confidence interval just to see how much it did go up. So I'm going to do x bar plus or minus t with 9 degrees of freedom, s over the square root of 10. So we did a one-tailed test, so that's a 90% interval. So let's see what, let's just go to let's go to t interval and data L3. Let's calculate that. So we get like 4.2 to 12.8, okay? 4.2 to 12.8. And what does that mean? Well, we're 90% confident that the average job satisfaction increased between about 4.2 and 12.8 after the exercise program was implemented. So for each person, the average job satisfaction increased on average about 4.2 to 12.8 points. Okay?